Hey guys, hope you're doing well. Today we're going to be talking about finding the side length when you're given us one other side length and an angle. So first we're going to go through a couple of examples. First example here, how would you solve this for this missing side length right over here? Should be pretty self-explanatory. Right, you just do Pythagorean theorem as always, right? And here, how would you solve for a missing side length? Let's say this shorter leg right here. It's a special right triangle, and as we covered before, if we have a special right triangle, there are a special set of rules. So this right here will follow under the special right triangle rules. It's a little blurry, but still same concept. It's yet another special right triangle. We could tell because of the 45-degree angle right up there. And the hypotenuse would just be whatever that is times the square root of 2, whatever this leg is. So in this case, it'll be square root of 6. All right, well, how about a situation like this? We're given the hypotenuse, and we're trying to find this side length right here, and we're given one angle, and we know it's a right triangle. I'm going to show y'all how to tackle this problem, and then we're going to go over it in more detail. Or actually, so I'm just going to draw this triangle once more. And I am not an artist, obviously. So we're trying to find this side length, right? We're going to go over the method on how to solve, but right now I'm just going to show y'all the steps and how you would. We're going to be talking about trigonometry. Trigonometry includes three properties. Properties such as sine, cosine, and tangent. Now there's a way to remember that, and it's kind of cheesy, but there's a way to kind of remember which way to use the properties and when to use the properties is a little phrase called SOHCAHTOA. Now again, we're going to go over what these mean later on. But first, let me show you First, let me show you how to solve this problem. Okay. Here, we're going to use the sine property. Again, I'll go over why that is later on in the video. Great. We're going to do sine of 43. Now, if you'll notice, your calculators, your scientific calculators, they're always going to have these three things. They're going to have sine, cosine, tangent somewhere in your scientific calculator. This is the time where you're going to be using this. Remember to always have your scientific calculator in degree modes. The way you're going to be doing that is you're going to press the second button, mode, and it should take you to a long menu screen with a bunch of options. There should be an option of radians or degrees. You should be able to make sure your calculator is in degree modes. Anyways, here we're going to use sine. Again, we'll explain further why we use sine later on in the video. We're going to use sine of 43. Remember, your degrees, which is 43, always goes in the parentheses. Always, always, always. When we're talking about regular trig, finding a side length, your angle is always going to go in the parentheses, okay? Now, your right side is always going to be a fraction. Okay, whether that fraction is yet to be determined. It depends on your specific right triangle. So here, you're going to have x as your numerator. And as you might have guessed, your denominator is going to be your hypotenuse, 25. Now, how do we get our x all by itself? Because we're looking for x, right? How do we get x on one side entirely? Well, we need to get rid of this denominator, and the denominator simplifies signifies division. Now, if we're dividing 25, how do we get rid of 25? More than likely, you're going to multiply by 25. And if what you do to one side, you got to do to the other. See, if I multiply 25 by the right side, this is going to cancel out. So on the right side, all you're left with is your x, which is exactly what you want. Here, you're going to end up with, don't overthink it. It's just going to be, as you see it right above, 25 times sine of 43. Now go ahead and type this in your calculator and you should get your answer you're looking for. First, I'm going to check if I am in agree mode. I am. And I'm just going to type it in as I see it. 25 times sine of 43. Now, you should be able to run this in your 10th, because your answer is going to come in the decimal form. X is equal to, we'll just leave it at 17.04. And that is one example on how you would use sine. I just noticed that on that one section of the video, you couldn't be able to see the whiteboard all that much. So I just wanted to show y'all what exactly I was writing. So here, originally I wrote sine of 43 is equal to x over 25. But I want the x by itself. So that's why I multiplied by another 25 on this right side. That's why I crossed it out to isolate my x. But as I said in the video, what I do to my right side, I have to do to my left side. So on my left side, I wrote 25 times sine of 43 is equal to my x. And I just plugged it into my scientific calculator using the sine button, which can be found right there. And it gave me 1704. Okay, now that we finished an example regarding sine, I'm going to show y'all an example regarding cosine, which is this example right here. Okay. This right here, and as you can see up there on the screen, is our cosine example. The way we're going to approach this is, you notice that we're giving different things. In the last video, or in the last example, I talked about finding a leg. Here we're going to be finding a hypotenuse. So we're giving an angle of 36. We're giving a side length of 19. So we're, like I said before, we're using cosine. And again, we'll get to this reasoning as to why we're using cosine in this situation. Just bear with me and keep track on your notes, right? As I'm on your own separate sheet of paper, write what I'm writing. So we have cosine as in our example. And what was the thing that goes in our parentheses again? That's right, our angles. Our angles always go in the parentheses. So here, in this case, our angle is 36. Again, our right side is going to be our ratio. What's the ratio? Let's find out. Here, it's not going to be our x as our numerator. Our numerator is going to be 19. And as you could probably determine, our denominator is going to be x. Here it's it's one extra step to isolate x, but don't be alarmed, all right? Before we had a ratio like this. Oh, excuse me. We had a ratio like this. And the way we were able to isolate our x in that situation was to just multiply by our denominator. And then here you cross it out, and then you're left with x. We've done our job. That was our previous example. Here, if we multiply by a denominator, what have we done? Really, we've isolated our 19 here, which isn't a bad thing, but we've isolated our 19. We need to get x on its side, on one side on its own. Well, what did we just do, right? What did we just do to the right side? We multiplied by x. So what do we need to do on our left side? also multiplied by x. Okay? So now we have x times cosine of 36 is equal to 19. What would you do? Well, let me ask you this. What would you do algebraically if I gave you 15x is equal to 19? This is a little side note here. What would you do here? You'd probably divide out this 15 to isolate your x, right? And then your x would be equal to whatever this ratio is. That's probably what you would do. Now, with that being said, just notice that this cosine of 36, it's just a plain number. Just like 15 was a number in our side notes, this is also a number. So you could divide this cosine of 36 out. Again, it's just a number. And what do you do to your left side? You got to do to your right side. What have we done, right? We've canceled out this cosine of 36 here. So now we've isolated our x. X is equal to 19 over cosine of 36. And if you were to type that in your calculator, you would get x is equal to 23.5. Now I know you're probably wondering, it's kind of the same process as we did with sine, but you're probably wondering, how do we figure out the ratios? How do we know to use sine, cosine, or tangent? Again, I promise you, we'll get to that later on in the video. Here is our last example. Of course, we're going to be doing tangent. As you can see, the examples above in the screen, we're looking for another leg, and this time we're not going to be using a hypotenuse. You see, a hypotenuse is not labeled, which means we're probably not going to end up using it. This is key for tangent. Okay? So I'm just going to write out tangent as we've done before with sine and cosine, and I'm going to make a parentheses in there. Now, what goes in my parentheses? Exactly. 53. 53 because it's the only angle that I'm given. I'm aware that we're given a right angle, but we don't ever use a right angle for these properties. We're using the angles that we're given besides the right angle. And just as before, the right side is going to be a ratio. Here, our numerator is going to be the x value. Once again, we'll go over later on as to why that is. And here, our denominator is going to be 7. Make sure to be writing your notes down. Do it just as I'm doing it, separated by sections of sine, cosine, and tangent. Here, we'll do similarly to the example of sine. We're going to separate the x. How do we do that? Well, you'll multiply by 7. Because if we multiply by 7, we get rid of this denominator, and boom, we have isolated our x. But what we did to our right side, we have to do to our left side. I cannot stress that enough. So we'll have 7 tangent of 53 is equal to x. It's a bit easier when your x is in the numerator, and by that I mean it's just one less step that you have to do. So then you'll have to do 7 tangent of 53 is equal to 9.3. Those are example problems. And we're going to go specifically with each one of SOHCAHTOA. Don't forget our SOHCAHTOA. We're going to go specifically what these mean, how do we use them, and what it's trying to tell us. Okay, so I designed stations for all y'all. Station 1 is going to represent SO in SOHCAHTOA. So let me write SOHCAHTOA once more. You could write it this way, or if it makes it easier for you to visualize, you could also write it this way. Whichever you prefer. I think this way you're going to visualize the ratios a bit better. Now, as you could probably imagine, and if you could read that, if not, I'll edit it in the video. But each phrase in SOHCAHTOA, it means something. Okay, y'all? So let's talk about so. So, right. Our S in so signifies sine. Okay. Our O signifies opposite. What I mean by that, it means opposite side length. Now we'll get to our previous example in just a bit. And our H, really hope y'all can see it, is hypotenuse. Okay? So let's go back to the example we saw for sine. Draw it out. 43 is here. 25 is your hypotenuse. X is your opposite side length. Now, first thing we should always look at whenever we have regular trigonometry questions, always find your angle. Always find your angle. And what I mean by that is our angle 43 is right here, correct? We have to look at where the side lengths are based on the angle. So, because our x value is opposite to the angle and our hypotenuse is visible, we know we're going to be using sine. Why? Because SOHCAHTOA. So represents sine is opposite over hypotenuse. Another way you can visualize it is sine is whatever our angle is equal to your opposite side length over your hypotenuse. Sorry, I know it looks kind of messy. Over your hypotenuse, right? So here, your sine is, again, 43, which explains why, in our example earlier, we put x on top of our ratio, because x is the opposite side length. It is across from the angle that's given. So it is our opposite side length. And our hypotenuse never changes. And what I mean by that is, in any right triangle, you could always distinguish which side length is our hypotenuse, which is why we use sine of 43 is equal to x over 25. Now, if you look back on your notes, you will see this is exactly our first example. This is why we set it up this way. Okay, I also set up a couple practice problems for each station. I'm going to only be doing one example problem for y'all in the video, but y'all can do the rest on your own. So let's go with problem 1, okay? And problem 1 is a right triangle. Here's your right angle. Your hypotenuse is 2. This leg right here is 1. And we have an angle right here of 30 degrees, okay? Based on what we learned thus far, why are we using sine? we're using sine right here because we find our angle, which is located right here, and we have to see which side lengths they give us. So they give us the hypotenuse, and they give us a side length that's opposite from the angle. Remember, this is opposite. That angle is opposite from that side length. And because we have an opposite, I'll put O, and a hypotenuse, which of these has an opposite and a hypotenuse, an O and an H? Well, that's right. It's our S, which signifies sine. That's why it's sine. So we'll just do this real quick. Sine of, what goes in our parentheses? 30, exactly, is equal to, what's our ratio? We follow this right here. We notice that our O is on top and our H is in our bottom. So our opposite side length is on top. So we have 1. And our hypotenuse is 2. That's how you'd set that up. Okay, that was station 1, which centered around cosine. Now we're going to center around, station 1 center around sine, which is our SO property in SOHCAHTOA. Now we're going to focus on CA. Remember, write this on your notes just as I'm writing it. Now, as you probably could imagine, our C represents cosine. Fix that real quick. And our A represents adjacent. And adjacent just means next to. By that, I mean whichever side length is next to the angle. And just as before, our H represents hypotenuse. So in our example before, in the beginning of the video, we saw an example for cosine, which was this right here. Our X is our hypotenuse. This value is 19, and and 36 is our angle, okay? Based on this, do you remember how we set it up? That's right, we set it up with cosine of 36 is equal to, now look here, our ratio is gonna look like adjacent on top and hypotenuse on the bottom. That's why we use SOHCAHTOA. It reminds us how our ratio is supposed to look. So, with that being said, adjacent just means next to. So which side length is next to the angle? We don't count the hypotenuse because the hypotenuse is a different side length of its own. So which angle, or which side length is next to our angle? It's 19. So 19 goes on top. And just like with sine, our hypotenuse goes in the bottom. Good way to remember this is when using sine and cosine, our hypotenuse always goes on the bottom. In this case, our hypotenuse is x, and that's exactly how we set up the problem earlier on. Just as before, I have example problems for each station. Last time I did question 1, let's do question 2 this time. So we have it that we have an angle of 51 degrees, a side length of 10, and our hypotenuse is x. How do we set this up, right? Well, we got to look at our cost section in SOHCAHTOA. Why is it cosine? Because we have an adjacent side length, which again, all it means is next to, and we have a hypotenuse. So because we have an adjacent and a hypotenuse, our side length, our property that we're going to use is cosine. So cosine of 51 is equal to your adjacent value goes on top over your hypotenuse. And from there you could solve. Try solving that on your own. On station 3, we talked about TOA. And as you probably could have guessed, our T stands for tangent. Our O and A stay the same. And by that I mean O still means opposite and A still means adjacent. Now, earlier in the video, I mentioned that something's missing whenever we use tangent. What was that thing? It was our hypotenuse. And as you can see, there's no H value here. There's an H value in SO, there's an H value in CA, but there's no H value in TOA. That's because we don't use a hypotenuse whenever we use tangent. A good way to remember this is, if you see an example problem that doesn't have a hypotenuse, you're going to be using tangent. Our example earlier was this right here, where your X is right here, here's your right angle, this is your angle that's given, which is 53, and this right here is 7. Notice, our hypotenuse is completely empty. That means we're going to be using tangent. Now, if you look at the ratio here, you notice that O is on top. What is our opposite side length here based on the angle that's given? It's X, which will explain why we set up our example problem earlier as this right here. Is equal to X is on top because our opposite is on top, and 7 is in the bottom because that's our adjacent value. And from here on, if you still need help, you could look at the notes you did previously whenever we were working on our example problems. Problem set up for you. Let's do number 3 this time. Here's our right angle. Here is our X. Here is our 9. And our angle is 32. Again, our hypotenuse is empty. There's nothing in our hypotenuse. Following TOA, we see that our ratio signifies that we should put our opposite side length on top of the numerator. Okay? So, once again, we're going to set up tangent. Our angle always goes in our parentheses. Our right side is going to have a ratio. As I said before, our ratio is 9 on top. 9 on top because 9 is our opposite. It's opposite from the angle that's given. And our adjacent is X. Go ahead and solve that problem on your own. Now that we have a better example or a better understanding of how and when to use sine, cosine, and tangent, let's try the word problem. A man spots the top of a tower that is 100 feet above the ground. The angle formed from the man and the ground is 36 degrees. What is the distance between the man and the building? If you're having difficulty visualize it, let's just draw it out sentence by sentence, okay? So the first sentence says, a man spots the top of a tower that is 100 feet above the ground. Don't stress, let's just draw the tower first. I'm not an artist, so I'll just keep lines. This is this is the height of the tower, and it is 100 feet above the ground. So the angle formed from the man and the ground is 36. So let's say this is our ground. Say the man is here. Let's say the man is right here. So what it means by this is the angle formed from the man, which is over here, and the ground is 36 degrees. This is assumed to be a right angle because a vertical building against the ground, it's perpendicular. And anytime we have something that's perpendicular, it creates right angles. Now I ask, what is the distance between the man and the building? So the man is over here, the building is over here. So it's asking for this distance right here. We'll call that our x. Now we're given a side length, we're given a side length, a missing side length, and an angle. Based on SOHCAHTOA, which ones, sine, cosine, and tangent, are we going to end up using? Are we going to end up using to solve? If you're struggling, remember, this is our hypotenuse, and yet there's nothing here. If we don't have a hypotenuse, which one of these doesn't have an h? Our TOA doesn't have an h. So that means we're going to be using tangent. What goes in our parentheses? That's right, our angle as always. Now, what is the ratio going to look like? Our O is before the A, so that means our O is going to be on top. So which side length is opposite from our angle? 100. And our A is at the bottom. Which side length is next to our angle, which is x? Now, how would you solve this? Well, we're going to multiply x on both sides. This cancels out our x here, which leaves us with x times tangent of 36 is equal to 100. Just as before, we're going to divide out this tangent. Divide tangent of 36. Our x is going to equal 100 divided by tangent of 36. That comes out to be 137.6. So that's the distance between the man and the building. There is a homework assignment. It's not too bad. It's 9 questions, 6 of them playing out triangles. 3 of them is going to be word problems just like you saw above. That's all I have for you today. Hope you enjoy the rest of your day. Have a good one.